Welcome to homework.
In this question, we are asked to calculate the percent dissociation of benzoic acid given that we know the concentration of benzoic acid. So, benzoic acid looks like this. There's a benzene ring and there's a carboxylic group attached to it. When this reacts with water, it will reversibly form this anion and hydronium ions. So the Ka value for this reaction is going to be the product concentrations, which is C6H5COO minus multiplied by the hydronium ion concentration divided by the product of the reactant concentrations. So since the Ka value is defined after getting rid of water from this equation, we can just write C6H5 COOH here, because the concentration of water is assumed to be 1 here, it being a pure liquid. And that we can assume that it's a pure liquid because there is very little dissociation of these species and a small concentration of benzoic acid. So Ka is this, and we see that because both the anion and hydronium ions are on the same side of the reaction, the amount of them produced are going to be equal to each other. So however much is being produced and however much is being used up in the reverse reaction of the anion and hydronium ions will be the same, meaning that the concentrations of these two species will be the same. For that reason, we can simplify the Ka expression for the Ka value. And then we can write it like this. So instead of the anion and the hydronium ions, we can just write the anions C6H5COO minus squared divided by C6H5COOH, which is benzoic acid. So using this equation, because we know the Ka value and the concentration of the benzoic acid, we can calculate the concentration of the anion present. So the main assumption here is that there is barely any dissociation of this weak acid, so we can assume that the initial concentration of weak acid that we started off with is the current concentration in this equilibrium. Okay. Let's try to do that calculation. Sorry about that. Okay, so using the previous equation that I showed, we can calculate the anion concentration And that is going to be equal to the Ka value multiplied by the benzoic acid concentration and we have to take the square root of that. Okay, so when we do this, we get this value 5.9 times 10 to the negative 3 molar. So that is the concentration of the anion, which is also equal to the concentration of hydronium ions. So once we know this, we can now calculate the percent dissociation. So the percent dissociation for benzoic acid is equal to the concentration of the anion divided by the concentration of benzoic acid multiplied by 100. So we just calculated the concentration of the anion, and that was equal to 5.9 times 10 to the negative 3 molar. And we are provided with the concentration of benzoic acid, which is equal to 0.55 molar. And we multiply this by 100, we get 1.1%. So this is the percent dissociation of benzoic acid.